All right, hello everybody. We're going to go ahead and talk about the design your own Serengeti experiment. You're going to need to have two things open, although you can just listen first and then open them. But you're going to want to open the simulation itself. So that's the simulation that we've been using for the last two assignments. And then you're going to want the requirements for this experiment also open. It's called Design Your Own or Design a Serengeti Experiment. Sounds like my dog might start barking. So if she interrupts, I'll pause while she barks. Okay, so let's take a look at the experiment. The basic idea of the experiment is that you get to mess around with the Serengeti simulation and you're going to change one variable. And you're going to change that variable in several different ways. And you're going to keep everything else the same. And then we're going to look at what impact changing that one variable has on your carrying capacity. Remember, that's the number. Remember, the graph, it always goes up or it goes down, but then it fluctuates and it kind of levels off at a specific level. And we say the carrying capacity is the maximum number that the environment can support without them going starving or whatever. So that's what we're looking for, is what impact does your little change have on the carrying capacity? Only you're designing it this time instead of just following my lead. So let me show you there. This is 18 points and it's summative. It is the kind of capstone of the ecology unit. So let's take a look at it. So it says, using the simulation, you're going to design an experiment that answers the question, how does blank, you decide, impact the carrying capacity of the ecosystem for the buffalo population at time 1500. So that means you're going to run the simulation. You're going to run it 4 times and you're going to run it to time 1500 each time. I'll say a couple quick things. On the Chromebook, each time you run the simulation, it takes about 5 minutes, so you need to be patient. If you change tabs because you get bored and you want to go surf the net or something, the simulation comes to a stop. And then if you come back, it'll start back up again. So don't switch tabs. Better to hang out on your phone for those 5 minutes than to be on your computer doing something else, because otherwise it won't move forward. And then the third thing I'll mention is that sometimes the Chromebooks, my computer does too. I'm working on a MacBook right now. Sometimes the Chromebooks slow way down if you haven't shut down recently. So it might be a good idea just to shut down your computer before you start this experimental design, and then have a fresh computer once you've shut it down. Okay, so let's take a look. Oh, it says here there's some things I'm going to change on it on my on the video. I'll fix this, but it says here you may work with a partner from my classes. You guys don't get to work with a partner, so you're going to need to do this independently. But I'll get this up to date for you. All right, so let's go ahead and jump right here to the research question. So it says, how does blank impact the carrying capacity of the ecosystem for the buffalo population at time 1500? Now you have to choose what you could change. So let's talk about some possible things that you could change. You're not allowed to change things that we already changed, but you're allowed to change them in new ways that we haven't changed them from before. So, for example, one thing you could do is take down all the fences. So, notice I unchecked buffalo fences, so there's no fences here. And each time you run the simulation, you could change the number of buffalo. Now, if you're going to do that, I want it to be in even increments. So, for example, if you start with 20 buffalo the first time, then I want to see it 40 buffalo, then 60 buffalo, then 80 buffalo. Not some random numbers all over the number scale, even increments. You could try adding wildebeest. So, what would happen if you had 20 buffalo and 20 wildebeest? Let me reset it so that you can see what it looks like when they add in the wildebeest. Give it just a second to think. I'll let it think while I'm talking. You could change the percent of grassland. So, there's grassland in the south, there's grassland in the central, and there's grassland in the north. We already changed, ruh-roh, we already changed. Let's see, I'm going to hit exit page for the moment and I'll have to restart it. We're not going to send feedback. Ugh, sucks. Hope I can get it to work for you. This is no fun. All right, we'll try it one more time. Hopefully, we can get it to work this time. Okay, so I said, what if we changed buffalo to 20? There we go. This is what I mean about shutting down your computer. I've been recording a whole bunch of videos and I've been running dozens of simulations, so it's time for my computer to shut down. That's why you need to make sure you do that. Okay, I'm going to hit setup reset. Hopefully, it will work this time. There we go. And so now you can see these little gray guys, they're not little. These are the wildebeest. And so they're going to compete with my buffalo the way I have it set up here. So here's a different example you could do. You could keep the buffalo number the same every time, but you could change how many wildebeest there are every time. Another thing that you could change, I will say I don't recommend the infect buffaloes or the disease or vaccine or anything. That doesn't work the way we want it to. So just don't worry about those. But you could change the percent of grassland in any area. You could change the seasonal rains, whether or not rain comes through. So those are all options that you could do. If you wanted to change the seasonal rains, let me just say that one really quickly. The way you would do it, you have to run your experiment 4 times. So the first time you would have no seasonal rains, so it's unchecked. The second time you would check seasonal rains when the time hit 500. So the rains start up at time 500. The third time you would have no seasonal rains until it hit time 1000, and then you would click seasonal rains. And then the fourth time you would have no seasonal rains at all, so it never rains. Did I say that right? The first time you would have seasonal rains the whole time, and the last time you would have no seasonal rains. I'm trying to give you some ideas of an experiment you could design. Now, here's what gets tricky about these experiments. You're only allowed to change one variable. So if you're messing with the seasonal rains and when the seasonal rains show up, you're not allowed to change how many buffalo or how many wildebeest or how much grass there is. Those all have to stay the same. Or maybe you want to change the percent of grass in the southern region. Sure, you could do 100, you could do 80, you could do 60, and you could do 40. Awesome. But then buffalo fences has to be the same, the number of buffalo, the number of wildebeest. You're not allowed to change anything else. They all have to be the same every time. So right now, let's say I want to mess, I put in 20 buffalo and 20 wildebeest. It doesn't matter, but I'm going to change the percent of grass in all the regions. So this one's going to be 80, this one's going to be 80, and this one's going to be 80. Okay, so that's one change that I made. The next time I do this experiment, I'm still going to have 20 buffalo, 20 wildebeest, I have buffalo fences. I'm going to take buffalo fences off. No buffalo fences. But maybe the next time I do it, I change this to 60, 60, and 60. So we're going to change how much food they have available. So notice that I'm only changing one variable. I'm changing the percent of grassland, but I'm not changing the number of buffalo and I'm not changing the number of wildebeest. It's the same. So that way we know that it's the percent of grassland that's causing the change in the buffalo and not the number of wildebeest or the rains or whatever it is. Okay, so a couple other things I'm going to mention. If you choose to have wildebeest in your simulation, I'm just going to go ahead and hit setup reset. Hopefully it won't die on me like it did. There we go. So we've got the wildebeest and we've got the buffalo, and I'm going to go ahead and click seasonal rains here. Watch when I make this graph. I'm going to go ahead and hit the graph, and it's going to show me both populations. So give it just a second. There's 2 lines that are being made. One line is the brown line, and that's for the buffalo, and the other line is a grayish bluish line, and that's for the wildebeest. And as it goes, you'll see it better. Maybe I'll make it look bigger. You can see that there's 2 lines here. Here's the issue. I don't care about the wildebeest, so I want you to unclick the wildebeest. So right here, I'm going to unclick them. All we want to see is what's happening to the buffalo. What impact are these wildebeest having on the buffalo? So I don't want to see the wildebeest line. I only want to see the buffalo line. Okay, so I'm going to pause this right now. I hope you're getting some ideas of things that you could change. Now let's see how you actually design the experiment. So let's go back to, where was it? Design a Serengeti experiment. There we go. Okay, so maybe our experiment is, how does changing percent grassland, all of them, impact the carrying capacity of the ecosystem. Okay, so that's my experiment. Now you need to have a hypothesis. What do you think is going to happen if you change the grassland, if you make there more grass or less grass? Independent variable, that's exactly what you're changing. So in my example, I would have said 100% grass, 80% grass, 60% grass, and 40% grass. That's my independent variable, and I spell it out exactly. The dependent variable, no matter what you're studying, no matter how you're designing your experiment, everybody has the same dependent variable. It's the carrying capacity of the buffalo. So at time 1500. So once it gets to time 1500, you stop and you look at exactly, watch what I can do here. Let's pretend this is time 1500. Let's say we got there. I can move my cursor to time, if that was time 1500, and it'll tell me exactly how many buffalo there are. So that's what you're going to look at 4 times. You're going to look at the ending number of buffalo, how many buffalo there were, and we're going to call that our carrying capacity. All right, controlled variables and constants. These are things that have to stay the same. So let's say I decided to change the percent grassland each time. So now I need to keep the number of buffalo that I start with the same, the number of wildebeest that I start with the same. I don't have to have wildebeest, but if I do, they have to be same every experiment. I have to keep the fences the same. I have to keep the rain the same. I can't change anything but the grasslands. So now I need to write those things. So same number of buffalo, same number of wildebeest, seasonal rains, whatever. I have to indicate what are the things that are going to stay the same in every experiment. All right, next we have to decide what the control group is. So a control group is usually the normal, or it's what the other groups are being compared to. So for example, for percent grassland, the normal would be 100%. If all of them were 100%, now we get to look at, okay, how did the buffalo do with everybody at 100%? And then if we changed it to 80 and to 60 and to 40, we compare how the buffalo did to how they did at 100%. So 100% is my constant. I'm sorry, I said the wrong word. It's my control group. I'm trying to think, if you were going to mess around with seasonal rains, we would say that seasonal rains happening the whole time, that's normal. That's the control group. And then you would compare it to seasonal rains only showing up midway through or no seasonal rains at all. How about if you're going to add different numbers of wildebeest? The first time you have no wildebeest, let's just see how the buffalo do with no wildebeest, and then start adding in different numbers of wildebeest and see what happens to the carrying capacity. So maybe you'd have 0 wildebeest the first time, then 20, then 40, then 60 wildebeest for your last trial, and you compare them. The one that has 0 wildebeest, that's your control group. All right, so next, now you need to take a screenshot. You need to take a screenshot of your control group. So let's say, I'm going to keep running this for a second. So I'm going to hit go pause, and they're still going. And let's say we got to time 1500. Now you need to learn how to take a screenshot on your computer, and you don't use your phone, use the computer itself. And I think I'm going to pause it here. Sorry. I think I give you instructions for how to do it. Yep, it says how to take a screenshot here. So click on that and it'll tell you what you need to do if you don't already know how to take a screenshot. And then you insert the screenshot right here in the image. So everything that I want to see, I need to see all of the sliders, the graph, and all the grasslands visible in my in your screenshot. So let me give you an example. I'm going to show you how I do a screenshot. This is how I do a screenshot on my computer. So I want to see everything. So this is what my screenshot will look like. This is what I want to see. I can see all the grassland. I can see all the settings that you had, and I can see the graph. And I would take that as my screenshot, and then I would insert it into the thing. Okay, the next section says run the simulation for your experiment number 1. So the first one, that was your control group. So that was your control group. Now you get to start messing around with one variable. So it says once your graph reaches time 1500, take a screenshot of the entire screen. Make sure that all the sliders and everything are visible. So again, it shows you every time you take a picture of all the sliders, what the simulation looks like, and stick it in here so that I can see how it all turned out. Next, you make a data table. What was your control group? So how was your control group different? So it was 0 wildebeest was my, I'm pretending that's not what it was, but 0 wildebeest was my control group. And then my experiment, I did 20 wildebeest, and then I did 40 wildebeest, you get the idea, and then I did 60 wildebeest, okay? What was the carrying capacity? So when I look at the graph, what did it say was the end? We're going to say the end is the same as the carrying capacity because it's a little bit complicated to calculate carrying capacity. So how many buffalo were there at the end? So at their end, it was 20, and this time it was 18, and this time it was 13, whatever. And you type those in for your what your carrying capacity was. Okay, the last thing that you need to do for this is called a claim evidence reasoning. You make a claim that answers your original research question. So do you remember that your original question, let's go back, was how does something, whatever you chose, number of wildebeest, for example, impact the carrying capacity of the ecosystem for the buffalo population at time 1500? So now you answer this question, make a claim. My claim is the more wildebeest that are added, the lower the carrying capacity for the buffalo. That's my claim, for example. That would be one example of a claim. So I'm going to answer the question right here. So I'm making a question, and it may or not agree or disagree with your hypothesis. Who knows how it turned out? Okay, then you're going to give two pieces of evidence. All you need to do for the evidence is state facts. When there were 0 wildebeest, the carrying capacity was 20. But when there were 60 wildebeest, the carrying capacity was 5. Whatever, it doesn't matter. But notice that I didn't interpret it. I just said the facts. When there were this many, this is the number. When there were this many, this is the number. It's just facts. 2 sentences. That's all you got to do. For reasoning, this is the most important section. You need to define carrying capacity. Remember, carrying capacity is the maximum number, write it down if you want to, the maximum number of animals that the environment can support, okay, without them starving to death or whatever, and explain how your evidence supports your claim. So my evidence was this number and this number, this. Why was it? So now I'm going to interpret. Let me go back and show. So when there were 0 wildebeest, the carrying capacity was higher for the buffalo because the buffalo weren't competing for food with anyone. Notice that I interpreted. This doesn't say anything about competing for food or that some were starving or hungry or they had lots of resources. And then for the other one, I would say, but when there were 60 wildebeest and the carrying capacity was much lower, the wildebeest were eating a lot of the same food that the buffalo were eating, so they were competing, and some of the buffalo were starving. Okay, that's me interpreting the results. That's called reasoning. Explain how your evidence supports your claim. Okay, one last thing before I go. I'm going to give you an example that I did. I purposely did one that I don't want you to do because we've kind of done this one before. Take a look. So I wrote my question. You can look at this anytime that you have questions. What impact does percent of grassland only in the central region, we already did this, in the central region have on the carrying capacity of the ecosystem? So there's my question. Here's my hypothesis. If percent of grassland changes from this to this to this to this, then the carrying capacity for buffalo will go down. Next, what's the independent variable? The thing I'm purposely changing? Percent of grassland. And I say precisely how I'm changing it each time. Dependent variable is the same for everybody, the carrying capacity. Controlled variables, what are the things that I'm keeping the same? I'm going to add 10 buffalo every time. I'm not going to have fences, and I'm going to have seasonal rains checked for the whole time. Okay, the control group, what's the normal? Well, I'm going to say the normal is 100% grass, and then I'm going to start decreasing the amount of grass. So the 100% grassland. So that's the control group right here. I took a screenshot of it, and it says just make sure that you can see all the stuff in this. And this isn't perfect. This should have the graph. I should have already done it, and I didn't do it already. So there's a graph there. Okay, and then here's my data. And then I just took screenshots of the graph, but I actually want you to take screenshots of your entire screen so that I can see how you set all of your sliders. And then we'll take a look at those, and you compare all of them. And then at the very end, it says, do the claim evidence reasoning. So I make a claim answering my question about how grassland impacts buffalo, reducing, this is my claim. Reducing the percent of grassland in the central region leads to reduction in the carrying capacity of the ecosystem for the buffalo population at time 1500. Okay, that's my claim. Then my evidence, really straightforward. I don't give any kind of interpretation. It's just straight evidence, percents, and the numbers. Finally, for my reasoning, I define carrying capacity. Look over here, like when you need to do this so that you can remember the definition. Carrying capacity is the maximum number of organisms, in this case buffalo, that the environment can support. And then for your how your evidence supports your claim, the number of the surviving buffalo was greater when the percent of grassland in the central region was higher. This means that fewer buffalo were dying of starvation and more were being born when there was more food available. I didn't write pages. I was able to do that conclusion, that reasoning section, in 3 sentences. I think you could probably do the same. All right, contact me or your credit recovery teacher if it's not me, if you have any questions or need any help doing this. But this is the summative for this unit. Have a great day and good luck with your experiment.